Finally, our one-sided limits. We have two options here. Really, we really could see a 0 over 0, but that was covered in the last section. If you do get 0 over 0, you have to do something. Do something. Okay. All right. So what happens here? We have number 1. We get, when we replace x with 0, we get 0 over 0. Okay, well, we have to do something. This one I find it's nice to remember what the graph looks like. So graphically, this is 0 here. The limit as x approaches 0 from the right. The value of the function will be 1. So the limit is 1. If you just replace if you made an xy chart, so you can look at it graphically. This here is the graph of this function, y equals absolute value of x over x. If you just replaced x with 1, and you get 1. How about 1/10? You get 1/10. You get 1, sorry. 1 over 100. X is approaching 0 from the right. 1 over 100, you'd get 1 over 100 divided by 1 over 100. And that's again 1. So the limit is 1. No matter how you slice it, you can do an xy chart. You can draw the graph. You could also replace absolute value of x with just x, because x is greater than 0. As x is approaching 0 from the right, x is greater than 0. So the absolute value of x, like what we talked about in the very first video, is the same as x when x is positive. And then x over x cancels, so x divided by x is 1. And there's a third way to get 1 for that limit. All right. And then for problem number 2, as x approaches 3 from the right, the denominator is approaching 0. It's not going to get to 0, but like we talked about, whenever you have a constant divided by 0, you're either going to get a positive or negative infinity. So we have positive or negative infinity, and I like to put this little bar here, and the numerator is going to be positive. We're just checking the signs. All we have to do is check the signs. As x is approaching 3 from the right, 3.1 minus 3, 3.01 minus 3. Well, no matter what number you replace x with, as long as it's bigger than 3 and you subtract 3 from that, the answer is going to be a positive number. So all you have is positive infinity. That would be a vertical asymptote right there. Now likewise, over here for number 3, the numerator is approaching negative 4. The denominator is approaching 0. The question is the denominator approaching 0 from the left, or is it approaching 0 from the right? If x is approaching negative 4 from the left, and you think about replacing this x with, let's say, negative 4.1, negative 4.01, and if you add 4 to that, you're still going to get a negative number. And so therefore you have a negative divided by negative, and then you get a positive infinity. Positive infinity. For number 4, x is approaching 0. Okay, then 1 over 0 from the right would be positive infinity. So it's 0 plus positive infinity. You just get positive infinity. And then for problem number 5, replace x with 1. 1 plus 2 is 3, plus 1 is 4. And then we have over 1 minus 1 is 0. But again, it's not actually 0. It's approaching 0. So we have to figure out, is that going to be negative or positive infinity? So we have the limit is going to be either negative or positive infinity when we have a constant divided by 0. If x is approaching 1 from the left, we have 0, 0 minus 1, 0.9 minus 1, 0.99 minus 1. All of those values that I just mentioned, when we replace x with a number smaller than 1, then you subtract 1 from that, you're going to get a negative number. So even though the numerator is going to be positive, the denominator is going to be negative, and we get negative infinity. And then finally we have the limit as x approaches 0 from the left of 1 over x. Well, that's going to be negative infinity because the denominator is approaching 0 but from the negative side, and so therefore negative infinity. So I hope you enjoyed that. Pause and rewind me if you need to. Fast forward me if you need to, but this is it, guys. Know these limits.